Hello everyone, I'm Tongyu Guo, the maintainer from the CNCF Sandbox project Fluid. And today I will introduce our project Fluid for you. And the most important is what is Fluid and why our slogan is use data in any way, use data anywhere and anytime. As everybody knows, using persist volume with the container storage interface address the data accessed in general schemas. However, it falls short of meeting the Unicode features of AI workloads. Firstly, because of the expensive cost of resources, combining the serverless and the server resources is a common choice for users to deploy the AI workloads. However, it requires a smart fuse client integration for environment adaptations. And secondly, AI workloads are inseparable from high-performance data accessing in hybrid clouds. But there is no native abstraction for distributed data cache layers. And secondly, during the AI application development, it is necessary to have a ability to dynamically mount the data size in a running pod. However, the immutability of the persist volumes due to the when the data set changes, it leads to the pod reconstructions. So, to address several issues, Fluid was initiated. Fluid is used to build container data distributed cache interface in Kubernetes. There are two key concepts in the Fluid. The first one is data site. It is a mutable data abstraction layer, and you can define a logical grouping of data source. You can define just like S3, HDFS, and NAS in here. And the second one, the runtime, it is a pluggable distributed cache system, such as Electro and JuiceFS. The data operation allows you to achieve data proactive data warning and migration processing. As mentioned above, Fluid provides a smart containerizing fuse client. It supports a dual mode. The first mode is the CSI driver mode. It achieves native persistent volume attachment, and we also provide a sidecar mode. It's designed for the service environment. It helps users to use data in any way. The benefit for the cache engine vendors, we provide a plugin-based fuse client integrations. We provide a unified plugin-based fuse client integration approach for multiple cache engines and allow cache engine vendors to achieve a low-code integration with zero code for CSI plugin. Fluid uses unified container resource definitions to provide a consistent abstraction of distributed cache systems in hybrid clouds. As illustrated in the diagram, you can see user can deploy and scale the cache systems in hybrid cloud by creating and updating the Fluid container custom resource runtimes, so they can cache data from the remote location to anywhere. For AI development engineers, using data anytime is crucial. This experience is easily to achieve in traditional VM environments, but it also wish to have the same seamless data usage experience in Kubernetes. So we achieve this by to provide a mutable dataset definitions, allow users to add and remove the multiple definitions in the data size, which has been used by a running pod. That's Fluid. You can use the Fluid to achieve the dataset abstraction, acceleration, and processing. By the way, Fluid has stood out in the latest CNCF Technology Radar Report, which it received widespread recognitions in the fields of batch processing, AI, and machine learning, and has been extensively deployed in so many users' production environments. And currently, Fluid has more than 500 contributors and 40 adopters. So we welcome you to join our Fluid community. Thank you all.